All right, welcome to Earth Science, everybody. So I'm going to have you play with what's essentially a toy, an internet toy. You'll go to that link. I'll have the link on the survival guide as well. It does take a minute to come up on these Chromebooks. Be patient. For a few minutes, it might just look like a black screen, depending on your internet speed. But it'll come up, and it's a gravity simulator. What it's meant to do is let you put up a couple of objects in a blank amount of space and see what would happen gravitationally. So if you go to build and you mute your computer so you can turn off that noise, they start you off with a basic one here, with a star with a couple of very small objects orbiting that star. And if you notice, the star is already wandering. Things pull on each other. Yes, the sun is pulling on the Earth. That keeps it from flying away, but the Earth is also pulling on the sun. So it wobbles as all the planets are moving around in a bit as well. And all I really want you to do is, honestly, just play with this for a little while and see if we can discover what are the things that affect the force of gravity. To start a new one, go over here to this little X. Is that clear? There's a lot of toys to play with on here. So, stick to doing a couple normal things first, and then if you want to, people do things with all kinds of planets running all over the place. But try to make some sort of orbit in the solar system. Now that one I just picked has a little tiny G with a line through it to say no gravity. So this one will not be affected by gravity. And then if I go and pick a planet, what you do is it's kind of like a rubber band. You click and you hold and you pull back like it's rubber bands. And then when you let go, it'll fling it off in the other direction. And it will orbit. If you're not recording a video at the same time, it should run a little smoother. So there you go. And you've already done the Sunlab. Think about that idea of a parent size of sun. If you lived on that planet, what would the sun look like from there? What would it look like as you got closer and closer and closer? Now, our orbit is nowhere near this, not circular. Ours is a lot more close to a perfect circle, but this toy will let you play with some of that. So that's like a planet. These would be small asteroids. And if the prize winner, and I try it every year, and I've only succeeded once, is to have a planet orbiting a star, and then a little moon orbiting that. It always gets flung off. It's very difficult to do, which kind of goes to show you that with these, even with just the basic rules of physics, Newtonian gravity here, getting the solar system set up just right for us to make it is kind of a tricky scenario. You can do dust. You can adjust all of the numbers on these planets, make them bigger and smaller. You can make the star bigger, smaller. Some of these, I don't quite remember. And if you really want to get funky, I don't necessarily recommend playing with these, but you can alter the laws of physics over here, which is going to complicate life, but hey, see what you can do. So can you set up a solar system? Can you set up something orbiting something that's orbiting something else? Play a little bit. And then at the end of the day, what we're trying to figure out here is what are the things that alter the force of gravity? And what do you notice? It's going fast right there and slow over here. If you notice that, you're starting to get down just by kind of noticing how orbital motions work and some of Kepler's laws that we'll get into. They're a little complicated. So play with this first, see if you can figure out, and we'll dissect the results later. Good luck.